All right, Living Environment fans, I'm off to see the eye doctor today. Now this is Thursday. You're watching this on Friday. So again, somehow I did this weird time jump thing. All right, let's see how it goes. All right. Hey now. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class. All right, I don't know if you can tell, but they dilated my pupils. So luckily pupils, the hole is bigger so they could look into my eye. They did all kinds of neat tests I'm gonna tell you about to check out the health of your eye. And it's like a lot of things we're learning biology, everything's connected. So your eyes can tell you a lot about the health of all the parts of you as well, especially your brain. All right, so I got to the eye doctor. So the first thing they did was took out my eye. Just kidding, they can leave your eyes in your head to examine them. I think this is just a prop from a movie. Anyway, but they did put a chemical in my eye to dilate. The colorful part of your eye is the iris, and it's full of muscles. And so what it does is just basically relaxes the muscles so that they dilate. So the hole becomes bigger. Like the pupil's just a hole and light goes into it. All right, and then why do they do that? So they can look at the inside of my eye. So the inside of your eye, right, tells a lot about what's going on. So here's the outside, right? This is the pupil, the hole. Right behind the pupil is the lens, right, which light focuses. But right on here is called the retina, and that's where all of the action takes place in your eye. And so by opening up the pupil, they can peer right into your eye. They shine a light in there, and they check out the quality of your retina. Right, here's a picture. This is what you might see. Right, you'd see some blood vessels, and you'd see the retina and the optic nerve. We're gonna talk about in a minute, but that's right. That's like your connection to your eye, to your brain. All right, so in the retina, there's cells, of course. I wouldn't be talking about this if it didn't have to do with cells. Right, the cells there's two different kinds of cells, basically rods and cones. But what's cool about them is they have cell membrane, plasma membranes, and embedded in those plasma membranes are various proteins, as you know. But these proteins are light sensitive. Okay, so light causes them to pump chemicals through the cell membrane. And of course, if you pump chemicals through the cell membrane, if you pump enough, you might actually cause what's an action potential or a charge. And this is how nerve cells send signals, by actually creating an electric charge by pumping chemicals through active transport of their cell membranes. And so in your eyeball cells, when they get hit with light, they will, depending on how much light hits them, they'll start pumping in chemicals, and that will send a charge down the cell membrane, which will then connect to the nerve cells, and then your brain ultimately will determine what it is you're looking at. All right, it all happens in the cell membrane, right? The phospholipid bilayer. There's some proteins there, and then activation, right? Light causes things to change, and then it causes enzymes to enact and do all these things, and eventually there's the sending of an electrical signal to the brain. They also do what's called a retinal scan. One of the things they do a retinal scan for is to look for anomalies in the retina, like how thick it is. This spot here where it's a little dip, that's called that's where the optic nerve is. And yeah, if there's changes in your retina, especially around the nerve, that could signal certain neurological problems like multiple sclerosis and other problems. Yeah, so it's kind of a window right onto the brain, because the eye is connected to the brain via the optic nerve, right? So it's like one of the few like brain types of nerves you can actually look at, is the optic nerve. Remember, when light comes through your eye, it comes through the pupil, it gets bent by the lens, and then it has to focus on the retina. If it doesn't focus, things are gonna look blurry. That's why some people need glasses to change where the focus is, so it's not blurry. Ah, now it makes sense. All right, let's do this. I think my eyes are back to normal now, but man, get my eyes dilated is, it's not painful, it's just uncomfortable, especially when I try to drive home It was nice and cloudy, but then it got sunny and I could barely see anything. I don't think that's safe.